Alright YouTube, back over here on this Trane RTAC. Verified that our nitrogen holding charge held over the weekend, so that's a really good sign. So what we're going to get started doing now is we're going to vent the nitrogen that's holding in the circuit. We're going to go ahead and pull the cover off of that, change the filter dryer core. I'll show you how to get that done. And after we do that, we'll set up the vacuum setup. We got the field piece. We're going to use some core removal tools. Got the True Blue kit and another Yellow Jacket vacuum rated hose. Get that set up and sucked it down. Okay, we've got the nitrogen vented, about to pull the dryer. These bolts are a 1/2 inch. There's a square nut on the back. You have to make sure you won't drop it and lose it. This isn't your standard size 48 dryer core. You're gonna have to order this OEM from Trane. So that's the part number. Kit 0614. It's not a charcoal dryer. It looks more like a filter. So let me get this pulled out and I'll show you what it looks like. Make sure not to drop that. Set these on the ground. As you can see, there should be a gasket right here. That kit will come with a gasket. Pull this little plunger off. You may need to get a pair of channel locks or a flathead to try to kind of pull this out, because it snaps into place. Go get a pair of channel locks, see if I can get that out easier. Okay. There you go. Sometimes you got to give it a little spin while you're pulling it. So that's what it looks like. Pause the video while I clean this gasket rim out. I'm going to want to get it nice and clean, and then I'll apply some nylon to our new gasket and get that in there. For those of you wondering, that's what the inside looks like. So we've got the inlet side of the dryer right here. Filters through here, goes through that hole right there. And it just kind of snaps in place. Again, there's an O-ring right here on the inside of this lip. You're gonna want to make sure you lubricate that really good. remove some of that oil that's sitting down in there. Okay, we got the inside of this all cleaned up. What I did is I just used some of that previously existing compressor oil that we had drained into a water bottle, lubricated both sides of this gasket really well. Okay. We're gonna set that down for the time being. Get our new filter, and remember we're going to lubricate the inside of this O-ring. Just using my finger with some oil on it. Lubricate that too. So we've got a nice good seat. Like that. We're going to slide this in here. Popped right into place. Our little spring is going to go back on the outside like that. Pressure on the back side of this plate, or that spring will push it out. I'm going to go ahead and just barely run this screw in so it catches on that nut and holds it in place. There we go. Now I'm going to do the same thing with all the screws. Just going to get them caught up on that nut. We don't want to fully crank it down yet. This one down at the bottom is going to be kind of tricky because of this insulation, so you're kind of have to finger fuck it. Okay, I got that on there. Now, like I said in the previous video in part 1, you're going to go opposite when you tighten these. So I'm going to tighten this one, and this one, this one, this one, this one, this one, so it seats evenly across the base. I'm going to keep my finger on the back side of this nut while I tighten it. Got that on there. Now, like I said in the previous video in part 1, you're going to go opposite when you tighten these. So I'm going to tighten this one, then this one, this one, then this one, this one, this one. So it seats evenly across the base. And I'm going to keep my finger on the back side of this nut while I tighten it. Okay guys, we got the core replaced. One thing I should note is if you're running those in with an impact or taking them out, it's best to use a ratchet to cinch them down. Your impact may start clicking and you think it's tight, but really you got another 3 or 4 quarter turns on each bolt. So I just set up the vacuum pump, field piece, 8 CFM. I've got a 1/2 inch fitting on my 1/2 inch True Blue hose, 3/8 Yellow Jacket vacuum rated hose. I've got the core pulled on the Drier core shell, so we're pulling from there, and I've got the core pulled right there on the suction line, pulling with my 1/2 inch. So we're gonna run the pump through the gas ballast and let it start to pull down, and then we'll switch over to pulling through the oil. I also have the core pulled right there. I don't know if I mentioned that or not. So we'll see. This is my first time using the field piece vacuum pump. We'll see how badass it is. It came highly recommended. I went ahead and just put my micron gauge somewhere further down the line so I can get a more complete micron reading rather than just putting it right there close to the pump. So I've got it right here. Whenever I start pressurizing the system, I'll of course close this little ball valve right here, keep the vacuum running, and then pressurize it. So we're gonna go ahead and let this run. It is 9:50 a.m. right now, so I'll keep an eye on the time and check back in with y'all whenever I've reached a suitable micron level. This circuit right here is so old, and because we have so many intricacies of the pipework and the compressor itself, pulling a 500 micron vacuum is going to be really tough. So if we can get below 1,000 and hold under 1,000, I'll be really happy with that. And of course, the lower I go, the better. But for a system this old that may or may not have some small additional leaks somewhere that we haven't located yet, 500 microns is absolute best case scenario. So I will check back in with y'all, let y'all know how it goes. Also, I had previously closed off this oil line when I was doing the repair to prevent oil from flowing back through. I went ahead and opened that valve back up so I can pull a good vacuum on the entire circuit. Alright guys, so it's been about 30 minutes pulling through my 1/2 inch and 3/8 hose with the core removal tools. Field piece VP87. This is a 250 ton chiller, so each circuit is 125 tons. For those of you guys arguing about pulling directly from the pump to core removal tools and still using manifold, I still do it every now and then, but the speed speaks for itself. It really is more efficient. So it's been about 30 minutes on a 125 ton circuit, and we're at about 3,000 microns. So the field piece manual states that once you hit about 3,000 microns, you should go ahead and close the gas ballast in the back right here and pull through the oil. So I'm gonna go ahead and close that, and then I'll keep an eye on the time and we'll see how long it takes to reach a suitable micron range. All right guys, so it's been about 2.5 hours. We are holding steady at about under 900 microns. So I'm gonna call it. That's pretty good for this 125 ton circuit that's really old on this screw compressor. I'm going to shut off my isolation valves, make sure everything's closed off, and then we're gonna recharge the system. I'll start by pushing what we recovered into the liquid line. I'll have it sitting on a scale so we can weigh it. We'll put in everything that we recovered, which was around 190 pounds. And then I've got a drum right there to top it off. So hopefully it'll take mostly everything, pushing it in under vacuum like that. And if not, then I'll turn the chiller to auto, and we'll push the rest in through the suction side. I don't think that I'll need to push it in with a recovery machine. It should take most of it. If I need to set up the recovery machine, I will. Once again, like I said, with recovering, it's going to be the same as charging on a chill water system. You need to make sure your pump is running. So before I get ready to put some charge in, the pump is set to automatically turn on when the chiller is in auto. I'm going to go ahead and switch this to hand, and that'll run the pump independently regardless of the automatic setting. So we'll leave the pump in hand. I'll put in all the refrigerant that I can. I'll switch it off, or switch it over to auto and turn the chiller on real quick. And I'll check back in with y'all, let you know how it goes. Okay, we're currently charging. The total drum weight was about 176 pounds for this drum. So the drum itself weighs 50 pounds empty. We are at 130, so I've got about 50 pounds in it right now. I know I've got pressure, so I'm gonna go ahead and put the schrader core back in, right there. I don't like to put the schrader cores in while the unit is still in vacuum. I don't want to risk any chance of getting oil potentially trapped in there. So what I'll do is I'll pressurize the system, make sure that I've got positive pressure, and then I'll put the schrader core back in. That way we eliminate all risk of any type of non-condensable getting in. So you can see when I swing around right here, I still have the schrader core pulled on this Drier port. So I'm charging liquid right here. Whenever it stops taking and the pressures kind of equalize, I'll isolate this valve again, take my hose off, and then I'll put the schrader core back in and hook back up with a regular hose at that point. So let's see how much it'll take in, and maybe I can avoid having to set up the recovery machine and push the rest in. Try to get this on film for y'all. So I got a new schrader core. I put just a dab of nylog right there. If you're not familiar with how to use a core removal tool, it's pretty simple. You're gonna slide this up into the top. Make sure your valve is still closed. Thread it in like that until it's tight. Now I'm gonna open my valve. That's gonna push pressure back against my core. So I'm gonna need to kind of press down on my finger and push against the depressor while I'm putting it in. Okay, it feels like it's tight. I'm gonna pull it back out, close this. And just to test, I'm gonna kind of keep my finger on it, and I wanna make sure no refrigerant is spitting it out when I open this back up, because there's not a depressor actually in this core removal tool. So you see I've got nothing coming out. My core should be in there. I'm gonna go ahead and unthread this. Back in there. Alright guys, well, it took about all it can take without using the recovery machine, so it's pretty simple to hook up. I've just got it in reverse order, as you would to normally use to pull gas from the system. So your inlet, instead of going to your gauges, is going to go straight to the tank, because the gas from the tank is going to go into the machine. Your outlet is going to go to your gauges and then be pushed into the system. So you're basically just reversing the order. I've kind of got this tampered down just a little bit because I don't want to slug the compressor that's inside the recovery machine. So we're going to go ahead and push the rest in. It's moving a lot quicker now. Check back in with y'all in a minute.
Hey everybody, DFW HVAC here. So I apologize for the lack of footage at the end of the video. Once those screw compressors got turned on and we started the system, it was just so noisy, you wouldn't have been able to hear anything that I said. So I kind of wanted to touch base with y'all on the outcome of the job. I wound up pushing in 230 pounds, which was the factory charge of R134A. Used around 180 pounds that we recovered, and then pushed in virgin R134A from some new jugs after that. So before I started up, I double and triple checked that I had every single valve open, especially the oil line, discharge line, all that stuff. When you're dealing with large tonnage equipment and screw compressors that cost $30,000 to replace, before you go starting it back up, you have to be sure that you've got everything open, or you can really damage the internals of that compressor, especially if you've got some oil lines shut off. So we made sure everything was open, started the chiller back up in auto mode, and pressures, first of all, set point was 44 degree water. We were reaching and cycling on that. Pressures looked really good. Had somewhere around 36 to 37 psi, so that's around 40 to 42 degree saturated refrigerant temperature. Had around 220, I'm looking at my measure quick right here. I had around 218 to 220 head pressure. Now that seems high for R134A, but for an air-cooled chiller that has parapet walls that are 12 feet high that surround the chiller, airflow kind of gets whipped around in there, that it never really escapes the envelope that it's in. And with it being close to 110 degree day in Texas, 220 is actually pretty good. So I think my subcooling seemed a little high. It was somewhere around 16 to 17 degrees. I'm not really too concerned with that though. My superheat was maintaining about where it needed to be. My metering device seemed like it was doing a good job. I had like anywhere from, it fluctuates 7 to 10 degrees. Obviously I couldn't get a Bluetooth clamp on the suction line because of the size, the diameter of it, so I had my fluke probe on there, pressed on with a piece of insulated tape about as well as I could get it. So anywhere from like 7 to 10 degrees superheat, 15 to like 18 subcooling, somewhere in that range. And unit ran good, cycled on set point. So I closed out that call. It's good to go for the time being. Thank you all for watching. If you have any questions, comments, or anything like that, please leave them in the comment section. Bear with me as I learn how to get better at making these YouTube videos. I'm still a total noob with this stuff. And if there's any special requests, leave them in the comment section. Peace, y'all.